Good morning, everyone, and welcome to another edition of Ask the SCSA, which we'll be hosting Tuesday and Thursday from 9 till 10. My name is Steve. I'm one of the safety advisors with the SCSA, and joining me today are my fellow teammates, Kieran, Laura, Kelly, Roger, and Adam. Let's just take a few minutes to go around the table here, starting with you, Kieran.
Good morning, everybody. My name is Kieran. I'm a safety advisor as well with the association. I work with the areas east and west of Saskatoon, so if you're in those places, get a hold of me.
My name is Laura Lodge. I have been a safety advisor with SCSA for almost 6 years now. Right now I'm just working in the Regina area, but I have worked in the Yorkton and Esterhazy region in the past.
Good morning and that there. My name is Roger Barriot. I'm a program auditor with the SCSA, and basically I run work in the southern area, so that's what I do there. So.
Good morning, my name is Kelly Champagne. I'm the Program Services Manager at the SCSA, and I look after CORE, C-CORE, the NCSO, and the HSA programs.
My name's Adam Drummond, and I am a trainer here at the SCSA, and we'll be doing virtual training and regular old classroom training eventually in the near future.
Yeah, and as mentioned, I'm Steve. I'm one of the advisors out of the Regina office. I'm good with the rookie here, almost 6 months experience with the SCSA. Before we jump in with the Q&A and stuff like that, I would like to do a little bit of housekeeping. Just a reminder to use the Q&A feature to get your questions in, not the chat. I'll be able to monitor that a little bit easier. If you're watching us live on Facebook, we do have somebody monitoring questions and forwarding them from there. So thanks, Kara, for doing that. These sessions are being recorded and will be available to watch later on our Facebook and YouTube pages. So the links will be provided on our website and social media channels. We're going to do our best to get to everyone's question today. But before we do have a few exciting updates and special events coming up, all of which you can either find on our website, the scsaonline.ca, or if they're not there yet, they will be very soon. So keep monitoring our webpage for those. And then we're going to have a very informative respiratory system presentation by Kieran to hear today. Let's start, Adam. There's some new updates coming out of the training department.
Yeah, I guess we've been working pretty hard at changing all our classroom training into virtual so that we're able to offer both classroom and virtual when that comes about. But right now we are offering virtual. We've just hosted our first Fall Pro class yesterday, which was a success. Everybody that entered the classroom was successful in passing it. So that plus we're going to be releasing Auditor as a virtual program next week. This week here, tomorrow and Thursday will be LSE coming out. That'll be our first LSE virtual. Other than that, we've got safety management that's being offered. OHC level 1 is being offered. Just keep on checking our online SCSA website to see the schedule and what classes we're offering. Or by all means, give us a call here at the SCSA. Somebody's always answering the phones. You'll be able to get your question at least transferred to somebody. And then we can tell you what classes we're offering.
Great, thanks, Adam. Also, upcoming this week, upcoming is the virtual celebration for this ongoing week of NAOSH and mental health. The NAOSH is the North American Occupational Safety and Health. This is their week. It's local chapters celebrating safety all over North America, Mexico, Canada, and the United States. So you'll find events on our webpage. We do have a virtual celebration this Thursday, May 7th from 12 to 1:30. The links to that are on our events page and on our Facebook page as well. So I invite you to join us at 12 o'clock. We have some great guest speakers from the from our very own Saskatchewan Construction Safety Association, as well as Labor Relations and Work Safety, the chair of the WCB, and the guest speaker from the Canadian Mental Health. So as mentioned, it is Mental Health Week to go along with NAOSH Week. So just a reminder, everyone stay mentally fit out there. There's lots of resources online, and on our webpage as well. Now I think it is time for Kieran to do his presentation on the respiratory system, and then we'll get into our Q&A after.
Fantastic. So good morning, everybody. This was a little passion project of mine. I decided to do this presentation as it kind of fits in with the current state of the world. So without further ado, we'll start. It's the particulates and fibers and how they enter the respiratory system and how you can protect yourself. So just some presentation objectives. It was to gain awareness of the respiratory system and how it protects you, and entry-level awareness on how to control particulate hazards, define key elements of the respiratory system, awareness of the hierarchy of controls, and basic measures on how to avoid pathogens entering the human body. So I just want to go over some definitions that I'm going to be using during the presentation here. So particulate. Particulate matter is the name given to solids or liquids that are distributed in a gaseous medium. Fiber. A fiber is defined as a particle that is more than 5 micrometers in length and having a length to width ratio of at least 3:1. A pathogen is a bacteria, virus, or other microorganism that can cause disease. And a virus is an infective agent that is too small to be seen by light microscopy and is able to multiply only within the living cells of a host. Bacteria is a microscopic living organism, usually one-celled, that can be found everywhere, and they can be dangerous or very beneficial, as the ones that are in our gut, and as we talk about with gut health. So a micrometer is equal to 1/1,000,000th of a meter. It's also known as a micron. And just branching off of that, a nanometer is equal to 1/1,000,000,000th of a meter. So this is just an introduction to the hierarchy of controls. So elimination, substitution, they all fit into engineering controls. The next step down is administrative controls, and then there's personal protective equipment. So PPE is always our last line of defense, or as noted here, least effective to most effective. So routes of entry. So inhalation is the most important route of exposure in the workplace, because when particles are in the air, there is a good chance you're going to inhale them. Inhalation is the most important route of exposure in the workplace, because a person working at a moderate level breathes 8.5 meters cubed of air, which is about 8,500 liters of air during an 8-hour work shift. So to get the idea of the capacity of the lungs, remember that your total skin surface area is only about 1.9 meters squared, so about 3.6 meters of skin surface area. So your lungs by far provide you with the closest and most extensive contact with the outside world. So the what happens also depends on the chemical and toxic properties of the material that you're going to inhale. Particles are deposited in the lungs by one of 4 different ways. So they're called interception, impaction, sedimentation, and diffusion. And I'll quickly go over those in a minute. How far the particle gets into the air passages of your respiratory system and what it does when it is deposited depends on the size, shape, and density of a particular material. So this is just a picture of the respiratory system. So it starts with the nose, where there's bones and cartilage that make inhaled air swirl so that large particles end up in here. Your mouth doesn't have any filtering system of that sort, but the same routes go down into your bronchus and your bronchioles. And down here, you can't really see them that well, but they are called alveoli, and they are tiny air sacs at the end of each bronchiole. And what those are the gas exchange regions. So that's where your body turns oxygen, gives it to your blood, and then the carbon dioxide comes up and it goes back out. So as I mentioned earlier, interception, a particle is intercepted or deposited when it travels so close to a surface of the airway that an edge of the particle touches the surface. So as you can see, it's not going to follow the airway, it just goes into the side here. This method of deposition is most important for fibers such as asbestos. The fiber length determines where the particle will be intercepted. For example, fibers with a diameter of 1 micrometer and a length of 200 micrometers would be deposited in the bronchial tree, as well as other particles. They'll just end up here, and then using what's called the mucociliary escalator, your body will actually pull the particles back up and out of your mouth. That'll be later on as well. So impaction. When particles are suspended in air, they have a tendency to travel along their original path. So when there's a bend in the airway system, for example, in your nose, there are many particles do not turn with the air, but rather stick to the surface on the particulate's original path. So imagine the nose breathing in right here, and it doesn't turn with the airways. The likelihood of impaction depends on the air velocity and the particle's mass. So typically, most particles greater than 10 micrometers in aerodynamic diameter are deposited in the nose or throat and cannot penetrate to the lower or the deeper tissues of the respiratory tract. Sedimentation. So this is an interesting one. So as particles travel through air, gravitational forces and air resistance eventually overcome their buoyancy. So buoyancy is the tendency for the particle to stay up in the air. So just as outside of the body there is gravity inside, and it will eventually, or most large particles will eventually settle onto a bronchiole, the bronchus, or somewhere in the respiratory system that's not getting to the deeper areas. This type of deposition is most common, like I said, in the bronchi. And sedimentation is not an important factor when the aerodynamic diameter of the particle is less than 0.5 micrometers. And then the last one is diffusion, which is also known as the Brownian motion. So this is the random motion of particles in similar to gas molecules in the air when particles are smaller than 0.5 micrometers. So what happens here is these particulates are so small that they don't react like particles, they act like a gas. So they'll bounce off of each other, noted by the squiggly lines here. So each turn is a reaction from hitting a different molecule, and eventually it will stick to the side of the lungs. So this is very common for asbestos to reach the alveoli regions, and that's when asbestosis becomes dangerous. So I'm just going to go over some basic engineering controlling strategies for airborne particulates. You're going to want to control dust at the source. So ways you can do that is using a water pumping saw when cutting stone to keep the dust down. Avoid breathing in silica particulates. Use what's called local exhaust ventilation, otherwise known as fume hoods, similar devices, and then dilution ventilation / building ventilation. So that just means having enough air to replace the contaminated air as long as the concentration is low enough. Sometimes that's not plausible to control at the source, so you separate the person that's doing the work into a different area. So an example of that is sandblasting done away from other workers to reduce their risk, asbestos abatement work, and people running vehicles out of the mechanic shop to test them instead of inside where dangerous hydrocarbons can stay in the air. Another thing you can do is change the process. And a good example of that is substituting airless paint spraying equipment for the conventional spray painting equipment that releases more aerosol into the air. So administrative control strategies for airborne particulates. So an administrative control is something a company implements to help work process become safer. So you can do that with work practices, safe job procedures. You can train employees for the tasks they're going to complete and others you'll get them to do. Again, some more on-the-job training by reviewing SDS sheets for the hazardous products if workers are unfamiliar, so that they can be aware of the inhalation hazards, as well as absorption and ingestion. Having excellent housekeeping programs and sweeping floors will keep nuisance dust down, as well as reduce the risk that certain things will get to a level. So personal protective control strategies you would want to use to correct PPE as outlined by OHS regulations, safe job practices, work practices, SDS sheet information, any governing body that tells you you have to wear the PPE, as long as you don't have other controls in place or the controls are not fully adequate. And you're going to want to choose the correct air purifying respirator with the correct cartridges, or an air supplying respirator if it is immediately dangerous to life and health. And you're going to want to ensure either of those devices are fit tested to a specific worker. So going off of that, we're going to jump right into respiratory protection, which again is your last line of defense. So an air purifying respirator work by removing gases, vapors, aerosols. So aerosol means a droplet or solid particulate in a gas medium, such as air, or a combination of contaminants from the air through the use of filters, cartridges, or canisters. And like I said before, it is definitely imperative that a person uses the correct filters, because a filter for gas will not work for particulates, and a filter for particulates will not work for gas. These respirators do not supply oxygen and therefore cannot be used in an atmosphere that is oxygen deficient, meaning it's less than 19.5% oxygen, or immediately dangerous to life or health. The appropriate respirator for a particular situation will depend on the environmental contaminant. So air purifying respirators must undergo qualitative, quantitative fit testing done by a qualified individual. And it's imperative as well that workers who use these air purifying respirators are clean shaven. So here are some common types of air purifying respirators. These are very common in the construction industry. So a disposable respirator, also better known as a dust mask, or N95, P95, N100, P100. So that's a very common mask. And an elastomeric half-piece respirator. So right here, this is common in construction as well. But for the sake of doing a hazard assessment, if you look at the SDS sheet of some materials, it will note that it is an eye sensitizer. So if that is the case, you have to get a mask that looks like this so it can protect your eyes as well as your respiratory system. So when you take a look at the masks that we get on a regular basis, the most common is an N95. So what that means is it's not resistant to oil, and it filters at least 95% of airborne particulates. So that's its efficiency rating. The P means some resistance to oil, and the R, the P means strongly resistant, and R means some resistance. So when you take a look at the other efficiencies, they're 99, which is filters at least 99% of the airborne particulates. And when they say N100 or P100, it means it filters at least 99.7% of airborne particulates. And again, these efficiencies only work and are accurate if the respirator fits and is fit tested. So to compare an N95 mask to the surgical style mask, just for the state of the world currently, these are some of the major differences. So the N95 designation means that when subjected to careful testing, the respirator will block at least 95% of very small particulates. so 0.3 micron test particles. These must be fit tested. They are disposable after each use, and they are being saved for medical professionals or occupations that normally require this protection. So these masks are designed to protect the wearer. So in a situation where we're going to a grocery store, the surgical mask is meant to block large particulate droplets, splashes, sprays, or splatter that may contain pathogens, keeping it from reaching your mouth and nose. And these are as well disposable after each use. So these have almost no particulate protection, as well as they don't seal to your face. So what they're good for is when you cough or when you sneeze, to practice respiratory etiquette for other people. So to branch off of this, asbestos is the big name in particulates getting into the lung. So we're going to go over asbestos and its dangers. So where was asbestos used and what is it? So asbestos is a naturally occurring mineral that was used in many residential and commercial building materials from the 1950s up until the 1990s because of its strong fibers and resistance to fire. When asbestos is disturbed, during renovations, tiny asbestos fibers are released into the air and inhaled. Asbestos fibers can get trapped into the lungs and cause serious health problems in the future, such as asbestosis, mesothelioma, and lung cancer. Asbestos is dangerous due to the way the fibers break down. So the diameter of the fiber continues to break into smaller sizes, which means it can get into the lower parts of the lung quite easily. And when those particulates do get into the lower areas of the lung, they form what's called fibrosis, which is scarring of the lung. And that reduces the amount of oxygen that you can transport to your blood in the long run. So it was used in flooring products, plaster, drywall joint compound, thermal insulators, fireproofing and acoustic ceiling tiles, and many other locations as noted by this little picture here. So some of the effects on the body. Asbestos-related lung diseases are the cause of many workplace fatalities in the province of Saskatchewan. In particular, mesothelioma and other asbestos-related lung diseases were responsible for approximately 23% of the 388 fatalities accepted by the Saskatchewan WCB in the last decade. So that's an extraordinarily high number for something that was last used 20 years, 30 years ago, potentially. So in 2018, 42% of the workplace fatalities were a direct result of occupational diseases. While many of these asbestos-related diseases are from the past, practices decades ago, actions can be taken today to reduce the exposure to this hazard. So some control strategies. Without proper training, equipment, and procedures, attempting to remove asbestos-contaminated materials can quickly put everybody at risk. So on the left-hand side of your screen, you'll see a hoarding, and that is the appropriate control for an asbestos-related situation. So people that are trained and qualified will set this up and ensure that it is airtight so that they cannot spread to other areas in the building. So it's imperative that if we find asbestos or we think we have asbestos, we call someone that is professional and knows what they're doing. If the proper respirator worn, it can protect an individual, but it will not prevent the hazardous asbestos fibers from becoming airborne and potentially contaminating other areas. So again, you just want to be sure that you have to be trained as well as qualified to be doing these jobs. So I know I've mentioned that you have to be clean shaven when wearing a respirator, and this is why. So when you wear a respirator and it's fit tested, it has to have 100% seal to your face for that 99.7 to be actually accurate. So if you look here, this is the size of a human hair, which is about, I would say about 70 micrometers across. And if you look at the asbestos fiber here, it's less than 1 or maybe even 0.5 micrometers. So if you aren't clean shaven, these fibers will have no problem bypassing the mask. From there, we're going to jump right into pathogens. So a pathogen is a bacterium, virus, or other microorganism that can cause disease. Starting with viruses. So a virus is an infectious agent of small size and simple composition that can multiply only in living cells of animals, plants, or bacteria. So they are considered the smallest living thing. They range in size from about 20 to 400 nanometers. So again, 1/1 billionth of a meter in diameter. These infections are contagious for varying periods of time depending on the virus. So when we hear the word incubation, that refers to the time between exposure to the virus or the other pathogen and the emergence of symptoms. It doesn't necessarily work with the contagious period, and it's not necessarily the same, pardon me. So some types of viral infections. So there's a respiratory viral infection that affects the nose, lungs, and throat. Because those droplets are so large, that's where they are deposited. And that's the type of respiratory viral infection that we're dealing with right now in the world. So these viruses are most commonly spread by inhaling droplets containing the virus particles. Droplets generated by coughing or sneezing are much larger than the virus contained in them. Just as regular particulates, the size in micrometers determines where they will be deposited. Some other viruses can spread through touch, saliva, blood, or even the air. Some viruses can be transmitted through sexual contact or by sharing contaminated needles, as well as some insects, including ticks and mosquitoes, can act as what's called a vector and transmit a virus from one host to another. Contaminated food and water are other potential sources of viral infections. So the COVID-19 virus is a respiratory viral infection and can be transmitted through touching your face, nose, and mouth, just because that goes into the respiratory system. COVID-19 cannot be transmitted through mosquito bites. And pardon me, studies have shown that COVID-19 virus can survive up to 72 hours on plastic and stainless steel, and less than 4 hours on copper, and less than 24 hours on cardboard. And that's from the CDC. So to give a good visual on how small a virus is, or look at the coronavirus here. So it's 0.1 micrometers, which is smaller than a bacteria, which is smaller than a particulate matter of 2.5 micrometers, a red blood cell, and a particulate matter of 10. So this is the size that will get stuck in your nose. So the size of the droplet, and the coronavirus would be in the droplet of that size. And that's where it depends how it gets deposited. So how you can protect yourself and others from the COVID-19 and other respiratory viral infections. So if you're feeling ill, don't go to work sick. Frequent hand washing, covering of the mouth and nose when coughing or sneezing, which is known as respiratory etiquette, and physical distancing can all reduce the spread of these infections. So disinfecting hard surfaces with an EPA-registered disinfectant and not touching the eyes, nose, and mouth will also help reduce transmission. So when you wash your hands, antimicrobial hand soap is a preferred method to remove pathogens from exposed skin. As well, using a minimum 70% alcohol hand sanitizer is effective as well. We're going to go to bacteria now. So bacteria are similar but different to a virus. So bacteria are found in every habitat on Earth: soil, rock, oceans, and even Arctic snow. There are approximately 10 times as many bacterial cells as human cells in the body. So again, there's almost 10,000 different bacteria in your gut alone. So those bacteria are all good bacteria, and they help and assist antibodies in your body to remove pathogens, other microbes, and they just help you out. But that being said, there's also the bacteria that grow and aren't your friend. So we have to protect against them as well. Bacteria can spread when residue from evaporated droplets or dust particles containing microorganisms is suspended in air for long periods of time. And that's what's known as a bioaerosol. So for example, if you had a diffuser in your house that you never change the water on regularly, or even a coffee maker, bacteria loves to enter something like that because it's a water reservoir, and that's where bacteria thrives, is in standing water. So some other pathogens that I'd like to talk about: a fungi, which is any member of the group of eukaryotic organisms, such as yeasts and molds, as well as the more familiar mushrooms. And there's a protozoa, which is an informal term for a single-celled eukaryote, either free-living or parasitic, which will feed on organic matters such as other microorganisms or organic tissues and debris. A worm, which is known as a helminth. Unlike any other pathogen, these worms do not proliferate within their hosts. Worms grow, molt, mature, and then they produce the offspring, which are voided from the host to infect others. So now, with all we've learned about the respiratory system, we're going to learn about how your body defends yourself against the foreign material and pathogens. So how breathing through the nose will protect you. The nose acts as a filter and an air conditioning for the air coming into your body. In general, particles having aerodynamic diameter of greater than 10 micrometers are deposited in the upper airway passages. So your nose, nasal cavity, and throat, largely what's known as impaction. That's because all the twists and turns that your body has naturally to collect those particles. This mechanism is prominent because of the high airspeed and the many turns in the nasopharyngeal airway. The changes in airflow direction cause many particles to hit the walls of the air passage, and so particles deposit or settle in this region. So going off of that, this is what the mucociliary escalator is. So this is one of the most advanced part of your bodies. So the mucociliary escalator is the apparatus that removes most foreign particles from your respiratory system. And it does so with the cilia. So the cilia, to look at it like this, are little arms that form a wave. So they go up towards your throat and they carry the mucus. And the reason we have mucus is so that we can get rid of the particles that we breathe in. So you might notice that you might become more stuffed up when you are in contact with dust, different particulates. That is a form of your body removing these particles from your body. So the mucociliary escalator is found in the trachea, bronchi, and bronchioles. And the only place that the mucociliary escalator cannot get to is the alveoles, which is where asbestos goes to, and that's why your body cannot remove those fibers. So immune system and your other defenses. The immune system is a complex network of cells, proteins, different bacteria that defends the body against infection. So your immune system will keep a record of every microbe that enters your body so it can defeat it if it comes back. Skin has a waterproof barrier that secretes oil with bacteria-killing properties. So intact skin will defend against most pathogens so long as you don't touch your eyes, your mouth, your nose, and the other entrances to the other parts of the respiratory system. So your digestive tract, when you have mucus and it goes up, the mucus lining in your stomach contains antibodies, and the acid in your stomach will kill most of the microbes. So your body has other defense mechanisms like the saliva and tears containing antibacterial enzymes to help reduce the risk of infection, and the constant flushing of the urinary tract and the bowel also helps. So that wraps up what I've had for the presentation, and if you need more information on COVID, you can be found on our website, scsaonline.ca. Under the resources tab, click into the COVID-19 coronavirus. There's links to many great topics, toolbox talks, different things that'll help your company out if you need some of this stuff and you're still working, as well as there's other great links on that webpage that'll take you to many other sources.
All right. Thanks, Kieran. That was very informative and on such an important topic. I think it's those hidden things that we don't think about every day, and bringing it up during the time of COVID makes it all that more real. But asbestos has been around for a long time, and as I saw in your presentation, lots of the claims coming through. This was all well before COVID and different viruses like that. There's been all sorts of different chemicals in the construction industry and other industries that we need to be wearing masks for. So definitely appreciate it. I was blown away by some of those numbers and visuals you had in there for just how small those particles are. So I'd like to remind everyone that this is being recorded. So this demonstration that you just saw can be shared with family, friends, co-workers. It's a great topic. Time to get on to the Q&A, guys. So let's delve in to the first one. It says, although dust masks are considered disposable, can they be used more than once for light duty tasks such as limited cutting throughout the day or cleaning and sweeping?
Okay, I guess the best answer for my part on the training side of things is that you always have to read those manufacturer specs. Respirators are made all different types, different uses. Your best bet to find out if you can reuse them is you got to read that manufacturer specifications. That is your ultimate, all your information on your PPE.
Yeah, no, that's really good answer there, Adam. Manufacturer specs is always good, and you really got to think about what you're up against as far as dust and that sort of stuff, and use that as a guideline when you're reading those specs. How should I clean my respirator would be a good follow-up, I guess, to that.
So with cleaning the respirator, it goes back to what Adam said. So you have to check the manufacturer's specifications for it, depending on what it is. Generally, obviously, the N95s, anything made of paper, you can't really clean those. So that's why they're disposable. But really, if you're using those half masks or full face, generally it's just like mild detergent, some warm water, letting it air dry, making sure that you wipe it with a lint-free cloth if you need to, and storing it in a bag. That's or somewhere in a container or something, so it doesn't get abused or collect dust and things like that. Yeah.
Okay. Oh, great. Now I've heard that cartridges can give off gas, dangerous chemicals, or fumes when stored on the respirator. Is it necessary to store them separately?
It can be. So the way some of the gas cartridges work is they have an absorbent material like activated charcoal. So depending on the type of cartridge, you'll have to check again with the specifications and make sure that it says storing potential, as well as if you can reuse it, all the things like that. So some cartridges are one-time use and some aren't. So you have to determine that and find the most practicable reason and way of getting around.
And I mean, just to add to that, I'm not sure, like that question kind of started with a bit of a giving off dangerous chemicals. I don't think that any device that's developed for protecting your respiratory system would in some way give off some dangerous or toxic chemical. I don't think it would really be on the market if that was the case. But again, like checking manufacturer's directions, because like Kieran said, it can, filters can degrade over time if they're not stored properly, right? And then they're not doing what they're supposed to do. So check the storage instructions, make sure that you're doing it according to what the manufacturer says is the best way to store it. And you know, get your information from the manufacturer, you know, try not to take second, third piece information.
Okay, great. Yeah, again, as always, refer to your manufacturer's specs. Going with the theme of filters, can I stack different filters? You mentioned that different filters can filter different items, you know, your gas particles and that sort of thing. Can I stack one on top of the other?
Absolutely. If it's designed for it, you can. If it's not designed for it, you cannot. But if the system allows for stackable cartridges, for an example, if you need particulate and a gas, then you'll be able to stack them if the respirator and the cartridges allow for it. It is very common practice to have them stackable.
Okay, and how do I know when my filter is done? Right, it's must when you're using it, is it good until you're done using it?
So there's a few different varieties of cartridges. So the newer cartridges actually have a little tab that pops out when they are saturated. In the past, you would have to determine if the material is hazardous. So for example, carbon monoxide does not have a sensitizing agent. So something with a good sensitizing agent or scent before the parts per million goes into your threshold limit value, which is the amount you can be exposed to without any adverse health effects, then if it has a good smell, then that's how you determine it. Some chemicals don't have a good threshold like that, so you will end up having no way of knowing. So replacing them on a consistent basis is your best, or if it's dangerous to life and health, then you will want to have an air purifying respirator instead.
Yeah, and again, it comes down to, I think, like the respirator, the manufacturer, and like the product you're working with and how much of it's like in the air, right? How much of it are you trying to filter out? Tell you how much filter you need, or if you need air purifying, if it's too much for a filter. Because usually the directions do say, you know, it should work for so many hours with different levels of products in the air or whatever it might be.
Okay, well, we're going to give Kelly and Roger a chance to participate here. So we're going to ask an audit question. During an audit, do auditors pay particular attention to respiratory protection? How should we be documenting inspections on these?
Okay, I'll get this one here. Yes, we do pay attention, especially in Section 6, personal protective equipment, because it is a specialized PPE, and we do have to take a look at that for respiratory equipment. And if they're not wearing it properly, or if they're not fitted, that's why somebody has to be trained in it and that kind of stuff to do it. And yes, you have to have documentation that is being properly inspected. And so we'll be looking at that too. And that's another portion of the audit that goes into inspections. So, and then also it goes back into another portion of the audit when it comes to training, because in training, you have to be trained in all that too. So you have to take a look at all three aspects of it all too. And then also when it comes to physical, there is areas where if they're not wearing respiratory equipment, we'll take a look at it, maybe giving them a deficiency. Like if they're working in a welding shop and the air quality is not very good inside that welding shop, well, they should have some kind of means of getting rid of the fumes and everything else like that. Local exhaust systems and that kind of stuff, so you could put that kind of things inside there. And then also when it comes to a lot of trucking shops and that, we go into a lot of those places. And there's a lot of trucks running inside there, especially in wintertime. And there's a lot of diesel fumes, which is also, if you look at the SDS sheets, they're also a carcinogen. And so that's something that you have to have some kind of way of getting rid of that too. So if you're not properly wearing your PPE, like I said earlier, that's something that we'd be looking at. So.
Okay, thanks, Roger. A very informative answer. Next question is going back to respirators. I'm not surprised there's so many with the presentation we had today. It is, do I as a worker need to provide my own respirator, or does my employer need to provide me with PPE? Whose responsibility is it to maintain PPE?
I can take that one. As far as a respirator and an employer providing it, it is a PPE item that an employer does need to provide for you, and also needs to also provide the training required to use that PPE or that respirator on how to clean it, store it, and all that good stuff. So your employer does need to provide you all that information. It also, just so that you guys know, I flipped through the legislation book quite a bit. And respiratory protection, where a worker is likely to be exposed to dust, fumes, gas, mist, aerosols, or vapors, or any airborne contaminants that might be present in any amount that are harmful or offensive to the worker, an employer contractor shall provide an approved respiratory protective device for the user by the worker that is used. There's a bunch of information there, but essentially that answers the question. An employer does have to provide you, it's right in leg on section 88 of the regulations.
All right. Next, going with respirators again. Are there options at all for using a respirator with a beard?
Absolutely, just not your normal one. You have to have like the full face mask or head helmet, I should say, not face mask, helmet essentially. There are options, but it is, I mean, you have to wear a full helmet on.
Okay, yeah, so for those of you that just absolutely are in love with your beard and can't get rid of it, there are those options. They're just not anywhere as easily available, but the option does exist. Next question. What are the avenues of getting my workers fit tested?
There's a lot of companies out there that do fit testing. So they'll come out to site, or you can bring your workers to their offices. As well, there are courses that you can put employees through where they can become competent in fit testing your own workers. If it's something that you need to do regularly, that might be a little bit more cost effective than sending people every time you need one. But again, it really kind of depends on the hazard that you're facing and the equipment that you're using. If it's, if you're using supplied air respirators and stuff like that, it might make more sense to send your workers to a course regularly on that, as opposed to trying to deem somebody competent enough to do the training on that in-house. It really depends on what you're facing and how many workers you have, but there's a ton of options out there to get fit tested. That being said, it might be a little bit backed up right now, but if you can give us a call and we can sort of put you in the right direction for that, or even just Googling it.
Okay, yeah, just with what you said, I was thinking that too. It could be backed up. So if you're at all interested in doing this, as with most things, the new online versions of many new classes are just getting running. So there's definitely going to be avenues to get your fit testing done, but definitely could be backed up. Now, can we have someone within our company do fit testing for our workers? And if so, how do we make sure we're doing our due diligence with that?
So when you take the course, I assume they will teach you how to fill out documentation, and they will teach you how to make your own form that includes all of the necessary things and topics to go over and all the content of the course. So the course itself is teaching you how to provide due diligence and how to train properly, as well as perform the fit testing adequately.
Okay, now does my worker need specific training? He's got 30 years experience in this, does he need specific training to be deemed competent? Like when you're coming to do an audit, are you looking at the training or training for the competency?
They have to be a certified trainer to be doing it, so they have to take it from a third party or someplace else to make sure that they're competent enough to be trained into doing the testing of it and that there too. So that's something that we do look at, because sometimes people just say, okay, I've been doing this for a while and that. And as an auditor, we got to take a look and compare it to the training that they've had previously or just having years. The grandfathering clause is no longer in place, so they have to have the training no matter what. So that's something that we take a look at.
Okay, yeah, as always, competency, right? Knowledge, experience, training. So make sure, especially if you're going to be teaching others, that you're absolutely sure you're doing it the correct method. Does the SCSA have a demo on respiratory safety?
Currently, we do not have a demo on respiratory safety, but I think that's a great idea.
Yeah, but just to go into that, we do have a confined space course that does delve into respiratory safety and that. You know, so awareness is something that we do offer in regards to that. Even that presentation you just saw Kieran do is another resource you can find on our website to bring awareness to your workers in regards to respiratory safety. So there is that. Does the SCSA course on confined, here's our confined space course right here, and respiratory protection cover much of what the presentation included? Do I need to take a course or training if I'm going to be using a respirator?
Yeah, in legislation, when it says here that your employer has to make sure that you know, so if a respirator protection device is required, it is provided to the worker by the employer or contractor, and then shall ensure that the worker has been trained by a competent person in the proper testing, maintenance, use, cleaning of the respirator or protective devices and the limitations. So there it is in leg. So you do need some training. Here at the SCSA, we give you a good awareness course. It's essentially just generic information that most respirators, or pretty much all of them, kind of follow. But then there is particular information that is pertaining to your respirator. So we give you a good chunk of information, but now it's up to you to find out exactly like the little details of that respirator that you're using. So an employer should be giving you that information. You should have a manufacturer specifications to refer to. So we give you a good portion of it, and then there's probably still a little bit that you need to learn from work, and the policies and procedures that your work might have as well.
Okay, great. We're going to go back to an audit question here. When core audits are being done again, can we still have our audit occur even though work has slowed to a crawl and our documentation isn't occurring as frequently as before? We don't have nearly the amount of work that we had before.
Yeah, unfortunately, I don't have a crystal ball and I can't tell you an exact date when everything is going to be going back to normal. The most important thing about your audits and your documentation is to remember that the audit is a snapshot in time. So even though you may not be able to have the sites and maintain your documentation to the extent that you were previous to COVID, we're going to take that into account, and we're looking at the whole year in effect. And if we need to, we can even go back. If it's a recertification audit, we can go back farther than that year and look in the previous 2 years as well. So in terms of sites, we are just actually working on developing a plan for our return to auditing. And we're going to be looking at what is feasible, what is going to keep the company's employees safe when we're out there, and what is going to keep our auditors safe when we go out. And we'll have to determine how many sites. Typically, right now, we require a minimum of 2 sites. that may be something that we'll have to look at in the future, just because of the change in economics for all the construction companies. And then we're also going to be factoring in travel, and again, as I said, auditor safety and the safety of the employees of the companies that we're auditing. So I wouldn't sweat the details of what you're trying to do as far as documentation during COVID. The auditors obviously are very aware of what's been going on for the last 2 weeks, or sorry, 2 months, and that will be taken into consideration.
Okay, perfect. It looks like we're running out of time here for more questions and stuff. So I do appreciate everyone participating in the panel here today. I just want to make sure I do a few reminders here before we are completely out of time. So I just want to make sure that everyone is aware of that it is NAOSH week. So a really good reminder to think about your safety programs and stuff like that. We should always be keeping our safety going, but our Thursday, we do have that great Thursday panel at 12. The link's on our events page. It's Mental Health Week, so we have a great speaker on that in that NAOSH Thursday talk. The theme for the Mental Health Week is social connection, and I think that is a very important theme this year with all the we've been calling it social distancing, but it's, you know, we really should be calling it physical distancing, because we should not be socially distancing from each other. There's just this avenue we have here of talking over Zoom or just being farther apart when you're having a conversation with somebody. It's that social connection between humans is very important. So make sure that you're looking into different avenues, especially during Mental Health Week, and remind yourself of that. Also, another reminder, again, next Tuesday, during the Ask the SCSA session, there's going to be a residential fall protection awareness. We will have, that will be in collaboration with the Saskatchewan or Regina and Saskatoon regional home builders. It'll be a great presentation on residential fall protection next Tuesday during the Ask the SCSA. Links to the Zoom and will be found on our website as well. And yeah, and then just a reminder on all the upcoming virtual training that we've got going on right now. Adam just gave us a few of the list. Fall Pro's up and running. More and more seats are being added as we move along and get going on staff. More classes are being added. So just keep checking the webpage, and if you need these courses, they're definitely becoming more available. Again, thanks to our entire panel for participating here today. And take care, everybody.